This video is about the assignment on chemical bonding, section B. Okay, let's look at this question. Lithium reacts with chlorine to form a compound called lithium chloride. Draw dot and cross diagram to show the bonding in this compound. You only need to draw the valence electron. So valence electron means the electrons in the outermost shell. So in order to do this question, first thing is to find out whether the lithium chloride is an ionic or covalent compound. Okay, ionic means metal, non-metal. Covalent means the compound formed between a non-metal and a non-metal. So you have to look it up in the periodic table. Lithium is a metal. Okay, it is to the left-hand side of the staircase, dividing the metal and the non-metal. Whereas chlorine is a non-metal, it's on the right-hand side of the staircase. So this one is an ionic compound. Yeah, so for ionic compound, the dot and cross diagram looks like this. You have two brackets, and then there is a charge here. Okay, then after that, so that will be the first step to find out whether it's ionic or covalent. The second step would be to write down the electronic configuration for lithium as well as for chlorine. So for lithium, the electronic configuration for lithium, so you have to refer to your periodic table, look at the proton number, okay? And the proton number for lithium is 3. So the electronic configuration is 2, 1. Okay, and then for chlorine is 17. So it is 2, 8, 7. So the lithium atom is 2, 1, electronic configuration, chlorine is 2, 8, 7. And in order for lithium and chlorine to be stable, so lithium will need to lose 1 electron and the chlorine needs to gain 1 electron. Okay, so when lithium loses 1 electron, so it becomes only 2 electron. That is why over here, the lithium, there are only 2 electrons left. Okay, so this X should be at the top here. Okay, because of the printing in the Microsoft Word, so the X actually shifted. And when it loses 1 electron, okay, so this electron need to be lost to the chlorine atom. When it loses 1 electron, it becomes a positively charged ion. Okay, so this plus should be at the top. And then for chlorine, it needs to gain 1 electron from the lithium. So it becomes 2, 8, 8. Okay, so that's why over here you can see that the circle actually means the electron for the chlorine. And then there is 1 X here. So this X is actually the electron from the lithium atom. So it becomes like this. And of course this minus, you have to shift it to the top. So this would be the dot and cross diagram for lithium chloride. Okay, hence write down the formula for lithium chloride. So lithium chloride consists of lithium ion, which is Li+, and chloride ion is Cl-. So since the charges are the same, so the lithium chloride will be LiCl. Okay, predict 2 physical properties of lithium chloride. Do this by completing the table, choosing from the word high, low, soluble, and insoluble. So you need to know the properties, the physical properties of ionic compound. Okay, so in your mind map, there is a table here. So you can actually refer to this table to find out the solubility as well as the melting point. So you can see that for ionic substance, okay, ionic substance, an example will be sodium chloride, your table salt. So the melting point is high. Okay, the melting point is high due to the strong electrostatic attraction forces between the positive and the negative ion. High melting point. And then the solubility, and of course for table salt, right, sodium chloride, it is soluble in water. Most of the ionic compound are soluble in water. So solubility in water is yes. That's why you have a high melting point and soluble in water. Alright, so that would be question number 1. Okay, let's look at question number 2. Draw dot and cross diagram to show the bonding in the following substances. You are required to show only the valence electron. So fluorine gas. Remember, fluorine gas is a group 7. Fluorine gas is group 7. So if you look at the periodic table, okay, the group 7 is actually here. So bear in mind that the group 7, they are the halogen. Okay, group 7, they are all diatomic. So which means that in fact for this 1, 2, 3, 4, 5, 6, 7, for these 7 elements, they are all diatomic. Meaning that they exist as F2, Cl2, Br2, I2, At2, and O2, of course, oxygen. Oxygen gas is O2, nitrogen gas is O2. So for these 7 elements, as well as the hydrogen, they are all diatomic. So in this case is fluorine gas. So we know that fluorine is diatomic. So fluorine gas, the chemical formula is F2. Okay, so fluorine gas is F2, and of course just now from the periodic table you should be able to see that fluorine is a covalent substance because it is a non-metal. So for non-metals, so for metal you have ions like this. They will lose or gain electron to form ions. The dot and cross diagram has a bracket. And for covalent substance, they share electrons. So again, the first step when you draw a dot and cross diagram, the first step is to find out whether it's covalent or ionic. So in this case, it's covalent. And the second step is to find out the electronic configuration for fluorine. So fluorine, you can refer to your periodic table. The proton number at the atomic number is 9. So electronic configuration is 2,7. 2,7 meaning that it is short of 1 electron. So when it is short of 1 electron to be stable, right, it needs to share 1 pair of electron. Yeah. So from here, we can see that each fluorine atom has 7 electrons of its own. Okay. So for this fluorine atom, it has 1, 2, 3, 4, 5, 6, 7. 7 circle. And then for this fluorine atom, it has 1, 2, 3, 4, 5, 6, 7 electron as well. Okay. 7 electrons of its own. And then it will share 1 pair of electron. And by sharing this 1 pair of electron, this fluorine atom would have 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's stable. And then this fluorine atom will have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this fluorine atom is also stable. So both fluorine atoms are stable, and that is why this is the fluorine gas, the molecule. So it is a stable molecule. All right. Okay, then magnesium fluoride. So when you want to draw dot and cross diagram for magnesium fluoride, again, you have to find out whether it's a covalent or ionic. This one, magnesium is a metal. Look it up in the periodic table. It's on the left-hand side of the staircase. So it is a metal. And fluorine, from here, we know that fluorine is a non-metal. So metal and non-metal, so it is ionic. And for ionic, the dot and cross diagram consists of a brackets like this. Okay, so that will be the first step, ionic compound. And then the second step would be to write down the electronic configuration for magnesium. Magnesium, look it up in the periodic table. The proton number is 12, so it is 282. All right, and then for fluorine, from here it is 27. Yeah, so over here 282 and 27. So in order for magnesium atom to be stable, it needs to lose 2 electrons. And in order for fluorine atom to be stable, it needs to gain 1 electron. So lose 2, gain 1. Lose 2 electron, gain 1 electron. But there is 1 more electron left. So in order for for the other electron that is left, then you need 1 more fluorine atom to receive the electron, to gain the electron. So in this case, you will need 1 magnesium atom and 2 fluorine atoms. So 1 magnesium atom loses 2 electrons. You need 2 fluorine atoms to gain the 2 electrons. Okay, that is why in your dot and cross diagram, you have 1 magnesium ion and 2 fluoride ion. Okay, so when magnesium atom loses 2 electrons, it will form a magnesium ion of charge 2 plus. And when a fluorine atom gains 1 electron, it becomes a fluoride ion with a charge of minus. And since there are 2 of them, you need a 2 here. Alright, so this would be magnesium fluoride. Okay, now the next question. Explain in terms of structure and bonding why the melting point of magnesium fluoride is much higher than that of fluorine. So this one is about structure and bonding. So if you refer to the mind map, or in fact your textbook also have, so you can see ionic substance. What is the name of the structure? Ionic substance has a giant lattice structure. Okay, let's take a look at what is this giant lattice structure. So giant lattice structure in your textbook, okay, it looks like this. So this is giant lattice structure. So this one is sodium chloride. So in a giant lattice structure, the positive and the negative ions are attracted to each other like this by a strong electrostatic forces of attraction. So this is giant lattice structure. All the positive and the negative ion. Each positive ion is surrounded by negative ion, and each negative ion is surrounded by positive ion. Okay, so you can see that the substance has a giant lattice structure, and then so this would be the structure. Then you have to explain the bonding. So that means what happened in the giant lattice structure. Okay, the positive and the negative ions are held in fixed position by strong electrostatic attraction forces in the structure. So whenever the question asks for structure and the bonding, you must have structure, you must have bonding. This is for ionic substance. Okay, how about for covalent substance? For covalent substance, the structure is called simple molecular structure. Okay, this is called simple molecular structure. So this one in your textbook, this is simple molecular structure. This is bromine, group 7. So you can see the Br2, the bromine molecules. Okay, all the bromine molecules, they are all far apart from each other. And they are attracted, all these molecules that are attracted by the dotted line, which is called the intermolecular attraction forces. And this intermolecular attraction forces is very weak. Okay. So, okay, the covalent substance, simple molecular structure, and then the molecules are held by weak intermolecular attraction forces. So in these questions here, it's talking about magnesium fluoride, which is an ionic substance, and also fluorine gas, which is a covalent substance. And then the question asks in terms of structure and bonding. So you must have 1, 2, 3, 4. You must have the 4 key points. Okay, so let's talk about magnesium fluoride first. It has a giant lattice structure. So in the structure, positive and negative ions are held together by strong electrostatic attraction forces. Okay, yeah. And of course, this strong electrostatic attraction forces is also known as ionic bond, but you don't need to write this ionic bond. Just need to write they are held by strong electrostatic attraction forces. And then for the fluorine, it has a simple molecular structure with weak intermolecular attraction forces. So these two paragraphs here is exactly the same as these 4 key points. Ionic, covalent. Then how do you tie in with the melting or boiling, with a high boiling and melting point? So you can say, okay, so fluorine gas has weak intermolecular attraction forces, right? So if the forces is very weak, you don't need a lot of energy to overcome the forces. That is why less energy is required to overcome the forces in fluorine as compared to magnesium fluoride. Yeah, so magnesium fluoride, because the positive and negative ions are held by strong electrostatic attraction forces, so you need a large amount of energy to overcome the forces. Yeah, so less energy is required, and less energy is required, therefore then you can add in one sentence to tie in with the melting point. Hence fluorine Hence, fluorine gas has lower melting point than magnesium fluoride. Okay, or you can say hence magnesium fluoride has a high melting point than fluorine. So again, the key point here is structure and bonding. So you must have structure and the bonding and the forces. Bonding is basically the forces. Yeah. Let's look at the next question. Chlorine is in group 7 of the periodic table. Use dot and cross diagram to show a chloride ion and a molecule of chlorine. Now again, chlorine is a non-metal, so it will form a covalent substance. Then the second step, write down the electronic configuration for chlorine. So chlorine, the proton number is 17, so it's 287. Okay, how about this chloride ion? So 287, it is not stable, so you need to gain one electron, become 288. Yeah, so chloride ion is actually after you have gained the one electron, become 288. That is why when you draw the dot and cross diagram, it will be 288. Okay, and then the charge is negative, chloride ion. Okay, chlorine atom, they will share. So this is very similar to the fluorine gas. Okay, show only the valence shell. So show only the valence shell. In fact, this circle is not needed. This circle is not needed. It is very confusing because the question asks for show only the valence shell. That means one electron shell. So supposed to have only one circle for each chlorine atom. So the inner circle actually no need to draw. Okay, let's look at number 4. Explain in terms of bonding and structure why ionic compound has the following physical properties: high melting and boiling point. Now this is actually very similar to question number 2. That means why magnesium fluoride has a high melting point compared to fluorine gas. Okay, so of course when you explain this, explain the structure first. That's why the structure is giant lattice structure. And then after that, explain the bonding. That means the forces in the structure. So positive and negative ions are held together by strong electrostatic forces of attraction. And lastly, you talk about the energy required to overcome the forces. Okay, this is very similar to question number 2. Okay, what is different is this one. Why ionic compound do not conduct electricity when solid, but conduct electricity when molten or aqueous. Now, in order for ionic compound to conduct electricity, the ions must be free to move around. Okay, the ions must be free to move around because the ions is the particle that can carry the electricity, that can carry the charges. So you can see, if let's say ionic compound is in solid, right, it will be like this. All these ions, all these Cl minus and Na plus, they are not free to move around. So that's why in solid form, ionic compounds do not conduct electricity. Yeah, but when they are in liquid, when they are in molten or aqueous state, what is the meaning of molten? Molten means melted. What is the meaning of aqueous? Aqueous means dissolve in water. Dissolve in water. So both are called liquid state. Okay, but for the conduction of electricity, you have to be more specific. You have to say molten and aqueous instead of just liquid. Liquid is a very general term. Yeah, so you have to be more specific. Molten and aqueous. Yeah, so you can look at the explanation here. In solid state, the ions are held in fixed position. Okay, like the photo that I showed you just now in the textbook. The ions are held in fixed position. And why are they held in fixed position? It is by these strong electrostatic attraction forces. Okay? And because they are held in fixed position, they cannot carry charges. However, when molten or dissolved in aqueous solution, electrostatic attraction forces have been overcome. Okay? the electrostatic attraction forces has been overcome, and the ions are mobile and can carry charges. So this has been summarized in the mind map. So you can see ionic compound can conduct electricity in aqueous or molten state. Why? Because the ions are free to move about to carry charges. Okay, all right. Okay, let's look at the next question. Okay, properties of sodium sulfide and carbon disulfide. So you can see sodium sulfide. Sodium is a metal, sulfur is a non-metal. Look it up in the periodic table. Don't believe me. Okay, metal, non-metal. So this is ionic. Carbon disulfide, carbon and sulfur. Carbon is a non-metal, sulfur is a non-metal. So this is covalent. So you can see here, deduce the type of bonding present in sodium sulfide and carbon disulfide, stating your reasons clearly. Very simple. Sodium sulfide is ionic, okay, because it's metal and non-metal. And this one, you have to state the reason must come from the data given. You cannot just say, oh, it's a metal and non-metal. Cannot. It has to be based on what the information is given in the table. Yeah, so you can see sodium sulfide. Why is it ionic? Because ionic has high melting point. Okay, and ionic does not conduct electricity when solid, but in molten and aqueous, yes. Yeah, so this is a reason. Reason is high melting point and conduct electricity in molten and aqueous state. And then for carbon disulfide would be the opposite. Low melting point, does not conduct electricity in all state. Carbon disulfide cannot conduct electricity in all state. Covalent substance cannot conduct, just like oxygen. Oxygen is a covalent substance. Can oxygen conduct electricity in solid, liquid, or solid, molten, and aqueous state? Cannot. Okay, so that is the reason. Okay, explain in terms of their structure why sodium sulfide and sodium sulfide conducts electricity when molten and in aqueous solution, but carbon disulfide does not. So this is very similar to the previous question. So you have to say in molten and aqueous state, what happened? Because the positive and negative ions are able to move around to conduct electricity. That means the strong electrostatic attraction forces have been overcome. And then for the carbon disulfide covalent substance, why doesn't it conduct electricity? Because it consists of simple molecules, simple molecular structure. There is no mobile ions present, hence cannot conduct electricity. All right. So I'm going a bit fast because you can see the repetition of the questions. I mean, the questions are very, very similar to each other. Okay, number 6, the incomplete diagram below represents the arrangement of the ions in crystals of either potassium chloride or magnesium oxide. Okay, copy and complete the diagram by adding the missing ions. So this is so you can see potassium chloride, metal, non-metal. That means it's ionic substance. Magnesium oxide also metal, non-metal. So it's ionic substance, ionic compound. And ionic compound, the structure is called giant lattice structure. And how does giant lattice structure look like? Okay, this is the third time I'm showing you this photo. Giant lattice structure consists of positive and negative ion attracted by strong electrostatic attraction forces. So you can see each positive ion is surrounded by negative ion, and each negative ion is surrounded by positive ions. So in this diagram here, okay, fill up for you ready. You can see each negative ion, it's surrounded by positive ion. Each positive ion is surrounded by negative ions. Yeah, and so are all other ions. So you just have to complete it. And then explain why both compounds have high melting points. It's the same thing as why ionic compounds have high melting point. So first of all, they are ionic compounds with giant lattice structure. And then, so this one would be the structure part. And then the second paragraph would be the bonding. That means the strong electrostatic attraction forces. And then the last paragraph would be on the amount of energy needed to overcome the strong electrostatic attraction forces. Okay, so the amount of energy required is large. Alright, so this is again very similar to the previous questions. So that would conclude the assignment on chemical bonding, section B. Thank you for watching. Bye bye.